Okay, this is the Module 15 review. Number 1, what is this expression simplified? Well, everything inside the parentheses is being raised to the power of 2. So that means the 16 is the first base. It already has a power of -1/2. You're going to multiply those exponents when you raise a power to a power. So that is multiplied to 2, and I'll make it a fraction, 2/1. Second base is x. It already has an exponent of 3/4. Raising it to the second power means times 2. I'll put it over 1 again. All right, we're going to simplify this. 16 is now to the power of, well, -1/2 times 2. The 2's cancel. It's just a -1. All right, x. I'm going to raise this so I have 3 times 2 is 6. And 6/4, let's write that over here. 6/4 is going to reduce to 3/2. I'm going to leave it in fractional form now so that I can actually do something with it. So 16 to the -1st power, remember that just means I need to put it in the denominator. So this is going to be 1/16 to the 1st power, which is just 1/16. And of course, this is multiplication here, so that means we're multiplying it to this x, which is going to be in a radical. Okay, the 2 on the bottom means it's square root. I can put a 2 here. I don't need to, though. And then, of course, we have a 3rd power on the inside here. So that comes from the numerator. All right, so this is going to be, let's put this over a 1 and just multiply across. All right, so we have this square root of x to the 3rd power divided by 16. I haven't done anything yet. We can simplify it still because this guy in here has a perfect square factor. So this is the same as the square root of x squared times another square root of x. Altogether, it's the square root of x to the 3rd. Still have the 16 on the bottom. And of course, you guys know the square root of x squared is just x. So I have an x there, that comes from that. And then I have the square root of x left over 16. So it's either that, or if you want to change this back to a rational exponent, you can do that. This is x times x to the 1/2 power over 16. I think I prefer the first one for an answer, but either one of those would be fine. Okay, number 2. We want to write an explicit rule and a recursive rule for a geometric sequence with a second term of 6 and a 3rd term of 12. So if I know the second term, let's do it like this. I'm going to make a table. I know you don't have a lot of room. Again, separate sheet of paper if you need to. Pause the video whenever needed. All right, so I don't know the first term, but I do know the second term and the 3rd term. It says the second term is 6, the 3rd term is 12. Well, I can see my common ratio since it's a geometric sequence. I know we're going to multiply here. To get from the second term to the 3rd term, I have to multiply by 2. So I know my ratio is 2. And I can find my first term right here by just dividing by my common ratio. So if I divide 6 by 2, because I'm going backwards, I get 3 here. So my first term is 3, and that will help me do both of these. So the explicit rule says f of n equals the first term, which is 3, times the ratio, which is 2 raised to the n minus 1 power. And the recursive rule, we have to first give them the first term. So here's the first term, it equals 3, comma. The nth term is just going to be the previous term. Remember, we used the previous term for recursive rule. And then we're going to take that previous term and multiply it by what to get to the next term every time here? By 2, right? And that works for everything greater than or equal to 2. Okay. number 3. What is f of x equals negative, parentheses, negative 2 to the x power, or evaluated for x is positive 2. All right, so here we go. We have f of 2 equals, I'm just going to plug in 2 where I see x. So we still have the negative here, and this is a positive 2. So I'm going to do this portion first, which means, marker small, okay, which means negative 2 squared, that's negative 2 times negative 2, which is a positive 4 when I square it. But then I still have to bring down this negative sign, so this f of 2 is a negative 4. Okay, number 4. Which of these sets of ordered pairs satisfies an exponential equation? An exponential equation means that I need a common ratio. I need to be able to multiply to get to the next term. So let's check this out. If I go from negative 1 to negative 8, what am I doing? I'm multiplying by 8. That means every time I need to multiply by 8 to get to my next term. Well, negative 8 times 8 is not negative 27, so that does not work. All right, to get from negative 1 to negative 4, I'm going to multiply by 4. And if I multiply negative 4 times 4, that gives me a negative 16, which is not negative 9, so that doesn't work either. All right, so let's try C. To get from negative 2 to negative 8, multiply by 4. Let's see, times 4 again. That does give me negative 32. Always got to check the last one just to be safe. Negative 32 times 4 is negative 128. So that does work. So that means D will not work. You can double check it. This is times negative 1, but negative 1 times 2 does not equal 6. What is the 10th term of the geometric sequence? Well, this is where it comes in handy to know how to write your explicit rule. So let's first find the ratio. The ratio is what do I multiply to go from one to the other. If you can't figure it out, always do the second one divided by the first one. So that's going to be 1/9 divided by 1/27. Okay? To divide fractions, we use our keep, change, flip. So we're going to keep this the same, change it to multiplication, and flip the bottom fraction. And 27 divided by 9 is, of course, 3. So our common ratio is 3. And now you could double check yourself, right? 1/27 times 3, that will give me 1/9. Okay, so once I have my ratio and I know my first term right here, it's pretty easy to write our explicit sequence, and then we can use that to find the 10th term. So let's start. We have f of n equals the first term, which is 1/27, times the ratio, which is 3 to the n minus first power. And we want to know the 10th term, which means we can plug in 10 for n. So we have, I'll do every step here so you see it. 10 minus 1 is going to give me 9, of course. So you can skip steps right here if you need to. Always good to write everything out, though. Okay, so 3 to the 9th power. All right, we got 3 to the 9th power. 3y to the x 9. That's a big number. We have, this part is 19683. I'm still multiplying that times the 1/27. So I'm going to put that over 1 just to keep it easy. Make it make sense here. So really you're dividing 19,683 by 27. Okay, so f of 10 equals 729. All right, number 6. We have a ball that's dropped from a height of 18 feet. We have a function that gives the height in feet of each bounce, where x is the bounce number. What will be the height of the third bounce to the nearest tenth of a foot? So we're going to have to round at the end. So what do we need to know? Well, we need to know what we're going to plug in for x, right? Because we have our function. Let me write this here. F of x equals 18. And we're going to plug in a number for x up here, which is going to be the exponent. Well, the height of the third bounce is what we want, so we're going to raise it to the third power. Okay, so if we raise 0.75 to the third power, we're going to get, let me write the 18 here first, we're going to have 0.421875. Okay, that's 0.75 raised to the third power. So this is actually f of 3, right? Not that that part matters. And multiply that times 18. And I'm going to give you the whole answer first, and then we'll round. So 7.59375. Maybe there was more. I don't know. We don't need all of it, though. All we need to do is round to the nearest tenth, which is here. So we need to look at the hundredths place. That's an arrow in case you didn't know what that was. That's going to tell me to round up. So it's approximately, I use the squiggly lines for approximate, 7.6 what? We're talking about feet here. Okay. Number 7. Is each of the following a geometric sequence? This is very similar to number 4, but of course this is multiple select kind of answer instead of multiple choice. And this time you don't have the x's, you just have the y's. So all we need to do is see, does it have a common ratio? Do I multiply by the same thing to get to the next term? So to get to, from -1 to 3, I'm multiplying by -3. I know that looks like x minus 3, but that to me says multiplying by -3. To get from 3 to -9, again, multiply by -3. And of course, to get to 27, again, multiply by -3. So that works. Multiply by -3 every time. That's your common ratio. This one doesn't have a common ratio, right? When I multiply, I don't get the same number as I keep going. So that's not going to work. Again, here, when I multiply, if I multiply by, let's see, -4 to get to 4, if I multiply again by -4, I don't get my -9. So that won't work either. The last one looks good. I'm going to do it down here because it's easier. Let's see. I'm going to multiply by -2, right? -1 times -2 is 2. 2 times -2 gives me the -4. I can write the times if you want here. And of course, that works again, times -2 to get an 8. So it has to have a common ratio in order to be a geometric sequence. All right, number 8, given that we have this f of x and g of x, determine if each is true or false. So I'm just going to write this on the side here because maybe you'll remember this. We have f of x equals ab to the x, right? Where the a is the initial value and b is the common ratio. All right, initial value, another word for that, of course, is y-intercept. And that's what A is asking about. So they're asking, do they have the same y-intercept? Is the A the same in each problem? Well, here's the A in f of x. Here's the A in g of x. So yes, they do have the same. Okay. B asks for the domain. So you have to think of what these graphs would look like. And if you don't know, you can always make a table. In fact, that's what I'm going to do right now. Okay, I took a second and just made a table there. All I did is plugged in a few numbers. It doesn't really matter which ones you plug in. You can pretty easily find the shape of these graphs. If I take and just sketch a graph of these, so let's start with f of x, which is here. I'm going to graph that one in red. All right, so if I start 1, -1 will be somewhere down here, we'll call it. 2, -1/2. Okay, as you see, as we get further down the x list here, we're going to get closer and closer to, looks like 0. So it's going to kind of do that shape, so in which case it will go like that, something like that. So that's our shape of f of x, and then g of x, we can get a shape just by sketching a couple of these. 1, -6. Let's see, that's going to be pretty far down here. 1, -6. Okay, so, okay, we have something like down here maybe. And as you get further along the x values, it's going to get more and more negative, okay? So it's going to get quickly more and more negative, which means it's going to go like that. As you get smaller, it's going to get closer and closer to 0. So it's going to look something like that. Okay? It's not perfect, believe me, but we just want an idea. Do they have the same domain? Well, domain in this case, x values, it's going to reach everywhere on both, right? It's going to go everywhere to the right, everywhere to the left. So yes, and in case you want to know what they are, they're both all real numbers. Do they have the same range? Yes, and if you don't understand this, you can make a bigger table and figure out where it's going to approach. They are going to approach this y is 0, but they're going to be everything below it, right? So everything y less than 0 would be the range for both. All right, and D, the graphs, are they both in quadrants 1 and 2? Well, that's also a no, because 1 and 2 are up here. This is 1, this is 2, so they're actually in 3 and 4. And it goes around counterclockwise. So 1, 2 is there, 3 would be here, and 4 would be there. So this is false. All right. Does each statement describe the end behavior for this exponential equation? All right, for this one, I also would like to get some kind of idea of what it's going to look like. You could pause and create a little table. So there it is. I made you a table. You don't have to do as many numbers as I did. You do as many or as few as you need to get the shape of the graph. Maybe you already know what the graph looks like, but you can always make a table to find the graph. So I'm going to go ahead and use this table quickly to just sketch this graph. So we're going to start with this -2 and a -0.3. Then we have a -1, getting a little bit smaller, smaller, smaller. We're rapidly getting smaller here. Okay, so we have, let's see, it's going to look something like this. Okay, it's getting closer and closer to 0, and it's then this is going to be right here. This 0 is -2/3. We're going to call that -2/3, and then it gets rapidly smaller from there. You could more carefully graph that if you want to, but I just needed a sketch. I needed to see which direction it was going and everything, so I can use that to help me. So A, as x approaches -infinity, all right, let's look at the graph here. So as x goes this way, what is the y doing? As you can see, it's getting closer and closer to 0. This is y equals 0 right here. So it is getting closer and closer to 0, so that would be a yes. So obviously it's not getting smaller and smaller really quickly. Okay. Now let's look at the other side where x is getting bigger. So as it goes this way, what is the graph doing? So you're looking as it goes this way, what is it doing? It's getting smaller and smaller rapidly, right? So it's not going to approach 0. It's going to get smaller and smaller. So that would be yes and no there. Okay. Back to some easier ones now. We have number 10. Simplify this. The cube root of 64. That's just what number times itself is 64. That's just 4. All right, minus the square root of 2 to the 4th power. Well, let's do the inside first. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16, and of course I want to take the square root of it. So 4 minus the square root of 16 is 4, and that's going to equal 0. Complete the table to find the values of the exponential function. Here we have to use a table. The other ones we didn't have to, but you could use them if you need to. And I always like referring back to a table. So when I plug in -1, and I'm going to show my work here. When I plug in -1, let's see, I have -2 times 1/2 to the 1st power. That's just -2 times 1/2. And that's just going to be -1. So when x is -1, y, I just realized I plugged in 1 and not -1. Let me fix that one. That one actually goes down here. This one. When this is 1, this is going to be a -1, but I'll show you the work for that one again too. So let's fix that one. We have a -2 times 1/2 to the -1st power. There we go. So we're going to plug in -1 here. We have -2 times, flip it, right? 2 over 1. So -2 times 2 is a -4. So this is -1, comma, -4. -2 times 2 is 4. -4. All right. -2 times 1/2 to the 0 power. Anything to the 0 power is 1. So this is just -2 times 1, which is -2. Okay, so let me do this one again. This is the one I did before. Let me make this smaller. Small. Alrighty. So -2 times 1/2 to the 1st power, I just did it, is -2 over 1 times 1 over 2, which is your -1. And 2, when I plug in 2, let's see, -2 times 1/2 to the 2nd power. All right, I'm going to get, let's see, -2 over 1 times 1 over 4. 1/2 squared is 1/4. When I multiply that out, I'm going to get, my 2 is my x, and of course this is -1/2, if you see there, right? -1/2. You could write it as a fraction, -0.5 if you want. And we can graph those. All right, so -2, -8. Let's scroll down a little bit more. -2, -8 would be down here. Whoops. Okay. Then we have a -1, -4. So that's in the middle of the x's there. 0, -2 would be here, and then it's going to be 1, -1. So 1 would be in the middle, -1 would be in the middle, so it's going to be right in the middle of this box. I don't like going by 2's, by the way, but we can do it. And then 2, -1/2. So here's the 2 line, but I'm not going to point it there, right? So there's the 2, and I want to go down just a little bit, so about there. So it's going to look like that, and they don't say anything about it being discrete, so I can go ahead and connect my dots. And there you go. Okay, we have some ordered pairs, and it says they're solutions to an exponential equation. We want to write the equation. Okay, so as long as they're in order, you know, this is smaller than this, so we're going, you know, further and further along. So we want to figure out, what do we do from 18 to get to 6? And it looks like we're going to divide by 3, but we need to say what we're going to do by multiplying. So we're going to multiply by 1/3. If you can't figure that out, you always take the second one and divide it by the first one. So 6 divided by 18, just reduce it, is 1/3. That's how I got my 1/3. So that's my ratio, or my b in an exponential equation. And I can find the a using one of these 2 points. Okay, it doesn't matter which one you use. Let's go ahead and use the first one. So let's write out the equation. Let's see. Can I move this? I moved b down a little bit so I have some room here. So first of all, I know an exponential equation looks like this. All right, and I know the b already is 1/3, so I can plug that in there. And this is what I'm going to use for x and y, or f of x, if you will. So 18 equals, I don't know the a, but I'm going to multiply it times 1/3, all being raised to the x power, which is -2. Let's find a. Okay, it's a times, well, 1/3 to the negative power, we need to flip it. And I'm going to write it over here. We have 1/3 to the -2nd power is the same as flipping it 3/1, which is just 3 to the 2nd power, which is 9. So this is an a. Let me make it more clear that this is an a times this thing, which is 9. I just figured that out. Okay. So then when I find a, I'm going to divide by 9 on both sides, so 2 equals a. So now my equation is just plugging in the a and the b. So f of x equals a, which is 2, I just found it, times b, which is the 1/3 raised to the x power. And they want us to graph this equation. And to graph it, I'll need to make a little table. Okay, this is up on the next side of that page. So we can make a table where we have 2 times 1/3 to the x power. And I'm just going to start with a -2. So 2 times 1/3 to the -2nd power is going to be 2 times, flip it, we just did this one, right? 2 times 3 squared, which is going to be 2 times 9, which is 18. So that's a first point. We have -1. When I plug in -1, got to flip that 1/3. So we have 2 times 3 to the first power, which is just 6. Okay, as I keep going, I'm going to get smaller and smaller. If I plug in 0, makes that one easy. 1/3 to the 0 power is just 1, so that's 2 times 1, which is 2. Let's do one more. Let's do -1. All right, 2 times 1/3, excuse me, +1, we already did -1. 2 times 1/3 to the first power is going to be 2 times 1/3, which is 2/3. So as you can see, we're getting smaller and smaller there. And let's sketch a graph. So I'm going to use my ordered pairs here. All right. So -2, 18. Let's see, -2 on the x-axis and +18 on the y would be way up here. -1, 6. Well, if that's 4, then 6 is somewhere about there. 0, 2, somewhere around there. And it's going to keep getting smaller, closer and closer to 0. Oops, not quite touching there, 0. That one looked like it touched 0. Sorry. Let's make it a little bit better. 6 was in here. And then we had, what, 0, 2. 0, 2 was here. Sorry, there we go. All right, let's do that. Okay, and of course that keeps going on up that way. Close enough. All right, number 13. Find the common ratio. What am I doing to get from there to there? It looks like I'm multiplying by -4. So the common ratio is a -4. What's the recursive rule? Well, I need to give the first term, which is a -5, and then the nth term is going to be the previous term times the common ratio. Don't forget the little blurb at the end, where n is greater than or equal to 2. It only works when n is greater than or equal to 2. And the explicit rule is a little bit shorter here. F of n equals the first term, which is -5, times this -4 to the n minus first power. All right, and number 14. For the graphs of f of x and g of x, are these following the statements true? All right, this is, again, you're probably going to want to make a table and sketch your graphs to help you out. All right, made you a little table there. You can pause and copy those down. I know my class has done a lot of tables at this point. Hopefully you know how to do that. All you're doing is plugging in x, picking some points. If those points don't work, pick different points. Just pick points near 0, whether it be just below 0 or just above 0. I just picked some ones above 0 here. And this is what I graphed. I graphed the point 0, 1, then I graphed 1, 2, 2, 4, and 3, 8. I did that with my red pen, and then I graphed the points 0, 1.5, 1, 2, 2, 3, and 3, 5. So if you look down here, I graphed those points, and I'm going to connect the dots for you. So this is going something like that, and of course getting closer and closer to 0 here. And the green is just not quite as steep, okay? So there it is. That's our sketches to help us answer these questions. F of x, let's label these. The red is f of x, and the green is g of x. So f of x is steeper than g of x. I'm going to say yes, that is true. What do we have? F of x is less steep. Well, obviously, that's a no. All right. G of x is a compression, meaning less steep. Well, we know g of x is less steep. Okay, and it's translated up the y-axis from f of x. Now look at the y-axis. This g of x is, of course, our green line. Is the green line translated up from the red line? Yeah, you can see it here. Let's highlight it right here. Okay, you can see the green is higher. So that is a yes. So then obviously the next one is asking, is it translated down? No. Okay, for a lot of these questions on the test, you're going to need to figure out the graphs. So get comfortable making your tables. I know it takes some time sometimes, but if you don't do that, then you have to memorize what all the things do. What happens when you change A? What happens when you change B? What happens when you make one negative and smaller than 1 and bigger than 1 and vice versa, everything. So that is your review.